Hello and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is another installation of the same problem. Body on incline, no friction, body goes down with acceleration, and we received in the previous solutions that A equal G sine alpha and N equal mg cosine alpha. And we investigated one alpha is 0, one alpha is 90 degrees, and our solution was in this coordinate system, right? And right now let's deal it with different coordinate system. I will change this y and x, and another natural choice would be like this: y is vertical, x is horizontal. We can do that, but this will involve more work a little bit. So mg in this system, the projection of mg is only on y, no projection on mg on x. So I don't want this picture at all, but I have n. N is going that way, right? And this angle is alpha. Because again, this is perpendicular to this side of this angle, and this, another side of this angle, is perpendicular to this side of another angle. So angles are the same. So that means that if I have horizontal projection, it would be this, and I have a vertical projection, it would be that. And if this is n, this is hypotenuse, then this from, or this is the same, or this alpha, from this triangle, doesn't matter. This would be n sine alpha, and vertical projection would be n cosine alpha. And picture will stay the same, forces will be the same, those two equations will be the same, but projection along x and y axis would be different now. And that's what I am dealing with. So mg I am projecting on x. mg has 0 because mg is vertical, x is horizontal, there is no projection. N. Projection n, I just got it, this is n sine alpha, right? So I get n sine alpha equal m. Now A is this direction, and if this is the angle alpha, then projection on this would be ma cosine alpha. Because again, from this triangular, A has now two components. One is x component and another is vertical y component. And so horizontal is A multiplied by this cosine alpha. A cosine alpha. And this would be A sine alpha. Right, okay. So I have the first equation. Now I go y-axis. mg is down, that means minus. And mg is full. That's the only projection, so it's mg. Now n is projection up, so it would be plus, right? Because y is up. And n, we now know that it is n cosine alpha equals m, and projection of A is down, so it would be minus, because we see that it's down, and it's A sine alpha. So there are two equations, n is unknown and A is unknown, two unknowns. Two different equations, but we have to work with this now. So how we will do? Let's find n from this. We will have n equals ma cosine alpha divided over sine alpha. Of course, I divide on sine alpha this, I divide on sine alpha this. This sine alpha is cancelled, so n is isolated and alone, and here is in the bottom. Or I just simply move sine alpha into the denominator of the right side, and I am happy. So n is done. And now let's put n here in the second part, and we will have mg plus ma cosine alpha divided over sine alpha, right? And I only put n, and then I put cosine squared alpha equals minus ma sine alpha, right? And let's separate our solutions that we already know, and now let's try to solve it. Now how we solve it? We have one a is our unknown, one equation, one unknown, because we reduce the number of unknowns by finding n from the first one and substituting into the second one, and instead of two equations with two unknowns, n is gone, we have one equation with one unknown. So now a is the only unknown, so we have to move everything to isolate a. So I will move this here, and I will move there. And simultaneously, well, I will not do any simultaneous thing. So I move those together, so it would be m a cosine square divided over sine alpha plus mi sine alpha, and so this moves here, sign is changed, which is formally is let's add mi sine alpha to both sides, so it would be disappearing from here but appearing on this side, and let's add minus mg to both sides, so plus mg to both sides, so this will disappear here, appear here, or I can move it here and change the sign. Doesn't matter, it's all the same, it should be very simple. Now let's multiply by sine alpha, and we will have mi cosine square alpha plus mi sine squared alpha equal mg sine alpha. So what I did, I multiplied both sides by sine alpha. So I multiplied this by sine alpha, and this sine alpha disappeared. I multiply this by sine alpha, and this becomes sine squared. I multiply this by sine alpha, and this becomes mg sine alpha. Pretty straightforward. I factor out ma. I receive cosine square plus sine square, which is 1, equal mg sine alpha. And m is gone. This is 1, and we have a equal g sine alpha, which is this. And if we will plug g sine alpha, sine alpha will go and will be cancelled from top and the bottom, and we will have n equal mg cosine alpha. So we have the same absolutely result, but I would say that with previous case it was faster. In this case it was a little bit longer, and it's simply a choice between how many projections you have to take. With this projection you have only mg to make projections. With these projections mg has easy solution, one only single projection, but n has this projection, n has this projection, a has this projection, and a has vertical projection. So more work, and it's not that straightforward. I mean, it's straightforward still, but you have to find and get rid of it. But the result is the same, and what it shows you that you can choose any coordinate system you want. You will receive the same result in any coordinate system. And, very important, it shows you that some coordinate systems are better than others in terms that it's faster. And of course, above all, you always have to solve it in characters. Imagine that I would have put here g 9.8, and your teacher gives you alpha 43 degrees, and I put sine 43, cosine, put the numbers, and how I will even solve it, I can't even imagine solving in the numbers right away. Right now, I can put here sine 43 degrees and whatever it is, and I will receive the result. So, as always, characters first, numbers in the last moment, and as you see, I often don't even plug the numbers because it's just basically plugging the numbers. Alright, and this would be a continuation to this problem, so subscribe and like and usual deal questions. See you next time.